Acids and bases are some cornerstones of chemistry that you need to know about if you're going to advance in the field. Now let's talk about classification of acids and bases and just what they are, and there are three definitions of them that we need to know. The Arrhenius definition, the Bronsted-Lowry definition, and the Lewis definition. In this course, you are most likely and probably will always use either Arrhenius or Bronsted-Lowry. So the basic idea is Arrhenius, this covers a good amount of acids and bases, but it leaves out a few keys. Bronsted-Lowry includes a lot of the stuff that Arrhenius might have left out, whereas Lewis is the most encompassing and covers basically every single acid and base. So with that out of the way, let's talk about a few strong acids and a few strong bases. There are 6 strong acids, starting with HCl, HBr, HI, phosphoric acid, which is H3PO4, H2SO4, sulfuric acid, and nitric acid, HNO3. So strong acids are all acids that are going to be very soluble, and as such, have the most potential to increase the concentration of hydrogen ions or hydronium in water, thus decreasing the pH and making it acidic. Now, strong acids can go beyond the known range of pHs, which is 0 to 14, because strong acids have the potential to even be negative if the concentration of one of these strong bases is high enough. And same thing with strong bases, if at a high enough concentration can go above 14. This is rare, and you won't see it in a problem, but it can happen. Now, in terms of strong bases, you have bases that are made up of alkali metals and alkali earth metals that are soluble, hydroxides that is. So we start with LiOH, lithium hydroxide, NaOH, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, and then we go into the alkali earth metals, which is going to consist of calcium hydroxide, CaOH2, strontium hydroxide, SrOH2, and barium hydroxide, BaOH2. So these are your strong acids and your strong bases. It's good to memorize them, but it's not a huge deal if you can't. Often it can help just to know these. But let's get started into our first definition, which is the Arrhenius definition. So the Arrhenius definition, like I mentioned before, is the most basic. Basic? Get it? Because we're talking about acids and bases. It's the most simple, and it does leave out a few things that we know are bases or acids. So one of the classic things that it leaves out is ammonia, NH3. We know that NH3 is a weak acid, and it's a very common one that's used a lot. So the fact that the Arrhenius definition leaves it out is kind of a problem. Thus, what the Arrhenius definition defines an acid as is anything that has hydrogen in it in some form or capacity. So all these strong acids are going to be acids under all these definitions. But in Arrhenius, these all have H's. And acids like acetic and absorbic, all these have H's to donate to water, thus creating hydronium, thus creating an acid. Meanwhile, an Arrhenius base will be anything that has a hydroxide. So again, all these strong bases, but see, it lacks, NH3 does not have a hydroxide, yet we know it's a base. So the Arrhenius definition is lacking here. Thus, we move forward into the Bronsted-Lowry definition. What the Bronsted-Lowry definition says is a Bronsted-Lowry acid will donate a proton, which once again is just an H plus ion, and Arrhenius base will accept proton. So in this case, NH3, which wasn't a base under Arrhenius definition, plus H plus just becomes ammonium, NH4 plus. And as such, we can classify it as a base. However, this is going to be the one that you use the most often in this class, but the next step is the Lewis definition, which is not tested in honors or AP curriculum, but it is still good to have a general idea of what it actually is. So, this definition is basically states that any substance that can accept a lone pair is a Lewis acid, and any substance that can donate a lone pair is a Lewis base. That is it in terms of acids and bases. I hope you enjoyed learning with me. I enjoyed learning with you.